Hello. Hello, Katya. Hello, Jose. All right. Hello, Kay. Hello, Abdel. Hello, Stephen. All right. It's like real people. Awesome. Awesome. Hello. And they beat me. And hello. Hi, Kirsten. Hi, Sarah. Hello, Gianna. Good afternoon. Good afternoon, Stephen. That's funny. Hello, Jose. Hi, Sumaya. Awesome. Hello, Brian. Top of the afternoon, Abdel. Awesome. Awesome. This is, oh, howdy. Wait, I just missed who that was. Wait, oh, sorry. Okay. Oh, and there's Sarah. All right. Awesome. Awesome. Oh, howdy, Kay. Good afternoon, Brianna. See, you know, in a way it's 2D, but in a way it's like 5D. Like I know so many dimensions of each one of you. I know your chat dimension. I know your avatar dimension. Okay. Anyway. All right. So we have, and my board is being my board again. I don't know what it's trying to connect. I don't know. It's limping along. It's coming, the board. So here's the story to get straight to it again. Just to be clear, we have an exam coming up. I hope that's clear to everybody. I hope if there's any questions about the details or the format or the expectations or the rules or etc. or the timing of the exam, hopefully all those details are clear in your Google Classroom. You should look, but if there's ever doubt in your mind, please text me or email me. More people coming. Especially if it's a concrete question, like texting might be faster. Okay, my board is still, hold on, let me just gonna, but hope, no. What is going on? Oh, sorry. I'm going to try again to get into the board. Hopefully it is clear that the actual exam will be hosted this Thursday evening, no later than 8 p.m., maybe a little bit earlier, but no later than 8 p.m. Due back, here we go. It's due back before 3:05 p.m. on the following Monday, the 14th. Again, this is what homework is all very loose in terms of deadlines and all that. You could still be turning in homework now for full credit, but you could even turn it in after the exam. And by the way, I would advise that if right now you're still worried about old homeworks or worried about getting them back, I would just worry about the exam right now. I mean, you should look at the homeworks to study them, But anyway, we're all loosey-goosey about the deadlines with homework. That is fine. But with the exam, you do have to turn it in by 3:05 next Monday. If there's going to be any issue with that, you have to let me know. Really. And I'll probably be cool about it as long as you communicate in advance. Same thing with showing up to class at 3:05 p.m. next Monday. If you're gonna, with that particular class, if there's going to be any issue with you showing up, you want to clear that with me in advance. Okay. Again, the procedures for this exam, it's a slightly unusual procedure. I don't want to keep talking about it. I'm sure you don't want me to either, but it is unusual compared to some other classes you've taken some. So you might have questions. It is true. I'm going to say again, it is open, everything. It is untimed, etc. And every rule or procedure governing this exam will be the same for the final exam in this class and will be the same for the 2 exams in Physics 204. So if you sort of get used to it now, that helps a lot. Again, just to be clear, and I want to get to it in a minute. Presumably you got the practice exam. You found it in your Google Classroom. Hopefully you've started to work on it by now. And I'm going to I think this class will be the most productive for people who have started to work on it, but it is for your sake, not for mine. You're not meant to turn it in at all. You should know that your actual exam will be remarkably similar to the practice exam. So the more you can practice with the practice in advance, the better you'll be. And we're going to go over aspects of the practice exam today. More people coming, sorry. you'll notice that just now, like a minute ago in Google Classroom, I posted a bunch of solutions to the practice exam. There are draft solutions. I mean, they're from an old document, so some of them you have to look carefully. Like some of the solutions are maybe to problems that were extraordinarily similar to yours, but maybe some details changed in yours. So be careful when you look. They're representative model solutions that are meant to help you think through what's going on, but they're not a government guarantee. If you have any confusion about any of the solutions, you should text or email me or something. But they're to give you an idea so that you're not stuck, or to confirm whether your answers are right or wrong when you get stuck. Today in class and Wednesday in class, mostly what I'll do is be solving problems from the practice exam. That's my way of reviewing. Especially Wednesday, I'll try to prioritize anything that anybody asks me about in the chat, or any solutions that you particularly want to see. I'll try to prioritize that Wednesday. Today too, but today I'm going to start with some things that I think you need to see that would help you. But any issues at all that you have with, you should really put in the chat. Any questions you have about the practice exam already, or procedures or anything like that. Again, most of today, we're going to be going over stuff from the practice exam, and anything in the practice exam is on the real exam. I mean, that it's a draft of the real exam. Again, anything that I fully solve for you from the practice, if I literally solve a problem for you, or if I post a solution like I did in Google Classroom, then you can assume that on the actual exam, a very similar problem will appear. But of course, I will change the numbers or change certain aspects to make sure that you're thinking it through and understanding it and paying attention, and not just blindly copying. If there's any aspect of the practice exam that I end up not giving you a solution for at all, and I actually think already there isn't. I mean, I think as of Google Classroom now, I think you have some written idea from me of pretty much everything in your exam. But anything that I didn't write out a solution or talk about in class, then you can assume that it'll appear verbatim in the actual exam. Okay, that's all. Last thing just to say, and again, I'm not, chat, the board's still not here. I don't know why my board keeps, hold on. There's something in the chat. I'm sorry. Hold on. Oh, good afternoon. Good afternoon. Sorry. Good afternoon, folks in the chat. Okay. Last thing. So again, mostly today and Wednesday, I'm going to be going over things in the practice. I'm going to be solving them. And then you're going to see remarkably similar things in the actual exam. The way to study for this exam is to practice with the practice document. It is not a trick. It is meant to tell you what to do to prepare. I would definitely do the practice above trying to read a textbook or anything else, or on all your notes and all the lectures to this point, and all your preparation, and also any supplementary thing that you ever do, like go to the MSRC or go to Khan Academy online, or any of those things are all great, but I wouldn't go to them first. I would try to do the practice exam, and then wherever you get stuck or you don't understand my solution or something like that, then go to those things and try to straighten it out and go to your colleagues. Bottom line, I know I've said this before, but I have to make this very clear because I know this is our first exam experience together. Let me remind you of a couple of things. This is like some classes, but it's unlike others. This is not a competition. This is a collaboration. Your chance to get an A is not threatened by somebody else's chance to get an A. I want there to be as many deserved, earned A's as possible. I don't have a limit on them. It's important to know that when you, sorry, wait, something in the chat. Sorry. Oh, yeah. Oh, that's a great question. In the practice, yeah. In fact, today, sorry, just to give you an idea. So someone in the direct chat, someone else is here. Someone in the direct chat is asking, today, can I go over some problems that finding out how far an object lands, like a particular part of the Yabber-Bomber problem or the chopper problem on the practice exam. Great. So that shows someone's studying, someone's looking at the practice exam, somebody already knows where they're having a little trouble or difficulty. Great. So yes, the answer is yes. Thank you for that. I would like to prioritize the concerns of people that have tried to study. So yes, the answer is yes. Not to mention that actually the Yabber-Bomber was something I was going to go over today anyway. I think that yes. So the answer is yes, direct chat person. Let me also, so I'm good. That is what I'm going to go over today, probably first, as a matter of fact. So great. But let me also tell all of you A couple of things. Hopefully you'll notice that every problem in the practice exam is like a problem that we've done before. It may not look like it at first. A classic example is like the Wile E. Coyote and Roadrunner problem. That may look, you might look at it first and say, we've never had a problem that had the Roadrunner or the Coyote, or we never had a problem where someone's going like this and doing that. But if you're studying enough, once you look at enough, and you look at the solutions, or you think about it with a friend, you'll see that that is the big old duck problem, just kind of turned on its side. I mean, it is the big old duck problem, just with details changed. Every problem in that practice exam, with maybe one exception, is a problem we've done before, just with just enough details masked so that you have to really understand the concepts and not just memorize the details. But so you'll hopefully see today. So for example, yes, I'm going to go over the Yavor-Balmer problem today. That is a hard one. And maybe in some ways to many of us might be the hardest one in the whole packet. I wouldn't be surprised. But I'll tell you right now what that Yavor-Balmer problem is based on. It kind of is big old duck, but even more specifically, what that Yavor-Balmer problem really is lab 4. Doesn't mean I'm testing to see if you perfectly understood lab 4 while you were doing it. You probably didn't while you were doing it. But now that you've if you use this practice exam to put together material, and as a chance, if you study through the practice exam, things will start coming together, and you'll see now how lab 4 relates to lab 3 or relates to the big old duck. But yes, I will go over that. But the more you can see how these different details are really just that, details on similar concepts, the more you will be progressing. Okay, but so good question. Thank you. Awesome. And my board's still not working. So I want to get to that. It's almost in a minute. That is literally what I'm going to get to, is the Yavor-Balmer problem. I was literally making a decision whether to do that or one other, but now that someone's asked that, yes, that's and I'll probably go straight to it too. I'll probably skip the chopper. Well, I think about whether I'll do the chopper first or not. But if I don't do the chopper first, I've just posted solutions in the Google Classroom that includes a solution to the chopper problem. Like when you struggled over it this weekend, or you didn't have these solutions, so they will hopefully help as well. But to everybody, oh my God, why is this? This is actually driving me crazy. Why is this not working? Hold on. Oh, don't want me. Hold on. I'm trying to clear memory here, so it may be a memory thing. So we're going to go over this practice now, but again, to everybody, just to make this clear, because once it's posted Thursday, you have all weekend to do it. You can go online. You can look at your notes. You can look at your practice exam. You can look at the solutions that I give you for the practice exam, and you can work with friends. When I say all that you can, I really mean it. I, in fact, mean that secretly, I would love it if you did help each other. I secretly want, it's not a secret, I want you to help each other. This is a very open universe exam. Now, that's unusual to some of you. It's so unusual to some of you that you might think I'm either crazy, or you might think you're misunderstanding me, or you might think I'm an idiot. Let me be clear. I am saying that there's a lot of things that you're used to consider cheating that will not be considered cheating on this exam. It is not cheating if you help each other. It's not. It's not cheating if you go on the web and get help on the web, even while you're taking the exam. That's not cheating. However, there is something that's considered cheating, and I'm super serious about it. So let me be clear, since you've never done this before, for me, you can get your understanding from whatever places you want in order to do this exam. You can get your understanding wherever you want, however you want, whenever you want. You can take as long as you want to get your understanding until the exams actually due, right? So even if you don't understand things now, you still have like a full week to put them together. But once you go to write this exam and turn it in by 3:05 p.m. next Monday, your job is to write down anything and everything and only what you personally understand. Let me be really clear about that. your job in your exam is not to show me correct physics answers. I already know the physics answers, and I'm giving them to you in many cases, and I know they're online. Your exam is not a good exam if you just give me the correct physics. That's not your job, because you will already have the correct physics in all of these solutions that I'm posting and going over there and all that. Your job in your exam is to prove to me that by the time you write stuff down, you understand personally why the correct solutions are the correct solutions. Your job is to prove to me that you understand what you're writing down, which means the more you write, the better, the more steps you include, the better, the clearer you are, the better, the more colors you use, the more diagrams you present, the more you put things in your own words. Your job is to present to me your personal, thorough understanding of these solutions that you and I both know will exist, and that you and I both know you will have talked about with your friends and all of that. I'm saying that all the stuff that normally constitutes cheating won't constitute cheating in this class, because I'm allowing you all to do it, and on purpose, right? I'm saying the things that are normally cheating won't be cheating here, because no one of you will be able to take advantage of rules. And in other words, it's not a situation where the rules followers and the people with integrity and the people with honor do one thing, and then the people that don't have honor and don't have integrity then cut corners and do something else and go to Khan Academy or whatever. And then the people that are good people get punished for being good people. That's the situation we're not going to have here. I'm saying you all should do anything and everything you want in order to get this understanding. But then once you turn something into me, you're only writing down what you understand. So the more you write down to show that you understand, the better. And the more honest you are about places that you don't fully understand, the better. You know the difference in your heart when you're just writing something that you got somewhere versus writing something that you now understand. And I got to tell you, I know the difference also by looking. I do. So what I'm grading on is authentic demonstration of authentic understanding. That's what I'm grading on. And I just want that to be clear. It means that everybody in this room has a shot of getting an A, even if they're still confused right now. But it means that some people will get bad grades for doing the wrong thing. And that's what will preserve the system for everybody else. Probably those people aren't even listening right now. But if you have any questions about that, you can text me or email me. But bottom line, there is a way to cheat on this exam, and that is to write down things that you don't understand. And that way, every single semester does reveal itself and does have poor consequences for the people that do that. Anything else is not cheating. Okay. All right. Sorry. Okay. Okay, sorry to take, so now, I don't know why my board's still, so I'd like to go over, I'm going to skip to I'm trying to get my board back on. I'm going to, come on. I'm going to go to the Yaver Bomber problem. I think it's either the second to last or the last problem in the exam, in the practice exam. It certainly is one of, oh, here we go. Okay. It certainly is one of the harder problems in the exam. It's very, sorry. Oh, okay, wait, something in the direct chat. Well, okay, so this is a good question. I'm not going to say the name. It's in direct chat, but someone's written in the direct chat. Sorry. Okay. Sorry, I'm getting confused. My board's doing weird things. Sorry. Okay. Someone said in the direct chat, at the exam, you want us to write out the concepts we do know. Well, it's not, I mean, that's a good question. I'm not really saying at the end, I'm saying that everywhere when you solve these problems, you should be fully going step by step and revealing like you should be doing the 5-step method for sure. But everything you do, like say you do some computation and you're in the middle of step 4 and you do some computation, and then like you divide both sides of an equation by 2 or something, and you say to yourself, does he really need me to explain that? Like I just divided both sides by 2. Is that like a step that or is that obvious? Does he? if you even think it in your mind, like, should I explain that I just divided both sides by 2? If you even can picture it in your mind as a question, then say it. Divide both sides by 2. Like every step of understanding you do to get to a solution is what I want you to explain out. And yeah, in step 3 of every problem where you do general definitions and principles, where you put down the concept that you're using to solve the problem, oh, for sure there, the better you can explain it in your own words, the better you show that you know what you're doing. That is what I'm saying, yes. But I'm not really saying, so if you do that correctly throughout all the problems that you're working in the exam, it should all be taken care of through the problems. I'm not saying that you have to make an extra section at the end of the exam where you explain the concepts you understand, but I'm saying that I'm saying this is not a copy paste thing. I'm saying that you're going to show me what you get by the way you write down the solutions. In other words, I'm saying one more time, and then maybe please direct that person, tell me if I'm actually answering this or not. I'm saying I'm about to solve one. Oh, okay, cool. Okay, thank you. Okay. So, and to everybody, like, I'm about to solve one of the problems right now. One of the ones that one of you just asked for, one of the ones I think is I wouldn't do it if I didn't think it was worthwhile, but I think one of you is asking for me to go over a certain problem in the exam. I'm going to go over it now, and I'm going to give you the answers. Okay. I might not even change all the numbers in this. I might be giving you the answers right now to the actual exam. I want to be clear about that. I know that, and I know that you know that I know that. I'm about to give you answers to the actual exam, in effect. So it can't be that you would get 100 by just spitting these answers back to me. Like, that's not what I'm looking. I'm looking for you to explain in your words with your pictures, and the better handwriting, like the neater you. I'm looking for a final copy that is really presentable and clear and shows me that you know what's going on. So it would be worth, that's why you're being given a practice exam. So you could do some drafts and some tries on this, and maybe and work with each other. Like, getting the right answers to all this stuff is maybe part of the process, but that's like step 1. Like, you're going to explain to me the right. All right, I think you get it. Okay, so I'm going to go over now. I'm going to go over now. I'll show you. I'll switch the screens. I'm going to go over. I'm going to switch screens. I'm going to go over one of the problems, and it's probably going to take me, I could see, it may take me all period to go over this problem, but it's a good one. I mean, it's thick. It maybe not, but let's say if it does, I'll go over more on Wednesday, and the more you can be prepared with the things you need to see on Wednesday, the better class will serve your purpose, right? So again, this is like a reward for the one person or one of the people that studied and has this concern. But let me also say that in the other class this morning, I went over a totally different problem, kind of on purpose. I went over the boat and stream bottle problem, which is also hard in a whole different way. Now that's on purpose. That in their class, I went over one, and in your class, I'm going over a different one. So I will post both the videos. I highly recommend that you watch the video later on when you're studying. Watch, or at least preserve, the video from the other class, because that's a whole other solution done there. That's like now 2/5 of the exam rather than 1/5, if you follow me. Okay. And I'll tell them the same thing to watch your video of this. But okay, I'm going to switch screens. Well, I'm talking about page. All right. Yeah. I'll switch screens for a second just so you could see. Okay. So I'm going over this page right here, right now. Page 7 of 8. Okay. I don't remember what it's part 3, problem 2 is what I'm going to go over right now. Again, partly because I think it's a very good problem to go over, partly because someone just asked. Okay, sorry, what time? 3:30. Okay. Can I get a show of hands if you're with me, if you know where I am, if you're with me, if you're ready? Okay, cool. Thank you. Okay, because now I'm going to switch the screens again. I'm going to go to the. Okay, great. Thank you. Awesome. Okay. So we've got an airplane driving south. So I'm going to say that's south. Let's say that's north. And then on the speed, there's no east or west isn't really happening in this problem. It's two-dimensional, but this is up and this is down, if you know what I mean. Okay. And we'll say, that for this purpose, south, because it's flying south, I'm going to make south positive. I'm going to make north negative. I can do that, right? This is Galileo. I'm going to make up positive. I'm going to make down negative. So I already have a diagram here, right? I'm doing Galileo. I'm choosing a coordinate system. I'm assigning plus and minus to each axis individually. So I'm just setting up the situation here. We've got this plane going, okay. And it crosses and it crosses this line known as the equator, right? As it's traveling north to south. And we're told that the whole aircraft is like 20 meters long from front to back. From nose to tail. Nose means front, tail means back. And it's flying above the ocean. So its altitude above the ocean is 1,000 meters. Okay, so this is a problem that is taking place in 2 dimensions, much like Lab 4 or much like Big Old Duck. Its 2 dimensions are being depicted here, but our whole idea is going to be that any 2-dimensional physics problem is really 2 1-dimensional physics problems occurring independently yet simultaneously. What's the other fact? Oh yeah, okay. So when it hits this equator, it like a bomb drops out. Maybe I'll. Oh yeah, no, okay, sorry. Yeah. As soon as it hits the equator, a bomb falls out of the plane, and the bomb it's released. It just falls out of the plane. Like it doesn't have any velocity relative to the plane when it falls out. In other words, it's not thrown, it's not thrust, and it's not thrusted in the angle or anything like that. So those are the facts. And last fact that we're given is that this entire plane takes 0.1 of a second to cross the equator, right? It's 1/10 of a second from the front of the plane to the back. Okay. So those are the facts. There's one other fact, which is a little confusing to be sure, and it sort of comes up in the problem later. One other fact that's given, and I'm also not quite sure how to draw it. Is that a bunch of stuff falls, the same 1,000 meters, a bunch of stuff falls straight down at the moment that this experiment begins. Like t equals 0. So t equals 0 is when the bomb is released from the plane. We're also told as a separate fact that at that very moment, a bunch of supplies are dropped from the top of a tower and just fall vertically down. Okay, we're told that. That fact is important. Okay, so all of these facts I just depicted in my step one, all this diagram I just depicted in my step one. I tried to label every fact or every number or every coordinate axis that I'm going to need to solve the problem. So I think this is my step one, my diagram and fact pattern. Please note, as a test taking strategy, we're given a lot of information here. Like I too, believe me, I agree. This is one of the hardest problems in the exam because there's a lot going on here. And if I look at this for the first time, I'm intimidated. Like there's a lot for my brain to manage for sure. But one test taking strategy is, oh yes, every fact that's given to you in a fact pattern is hopefully important. Hopefully no one's trying to trick you and give you distracting information. But that doesn't mean that all these facts are all going to be important all at the same time for every single part of the exam, of the problem. So all these facts are going to come into play. That's why I'm sort of making a diagram of them. But now I'm going to proceed step by step and just only think about the facts that I need for each step as I go, right? I mean, that's not cheating. That's good test taking strategy. Don't try to take this all in all at once. Take it piece by piece. But yeah, what's happening is we got a plane going forward to the south. It dropped something. And at the same time that it dropped something, from it, some bunch of supplies just fall from a tower toward the ground. Okay, that's the situation. Okay, and I'm looking at 3 screens simultaneously, so please let me, if you have any I think it looks like there's nothing in the chat. I can't tell. Okay. Wait, there's something in the chat. Wait, this is a great question. Great question in the chat. Okay, I'm about to solve this problem. I don't know when this goes. 3:35. Okay, two minutes ago. Someone in the direct chat, really great question, and thank you for paying attention. Someone in the direct chat is asking, for the exam, do we treat free fall acceleration as like -10 meters per second squared or -9.81 meters per second squared? They're asking -10 or -9.81. Great question on many levels. Okay, so first of all, on the exam, whenever numbers are involved, like this problem, numbers are involved. Let me back up even further. He's or she is definitely right to assume that the constant acceleration due to free fall is involved here. For sure, things are falling toward the surface of the earth. This is definitely a problem that involves free fall. If there were no numbers in this problem, I would just leave free fall acceleration as lowercase g. There are numbers in this problem, so yes, that person is right to ask, what number should we assign to g? And I'll tell you right now, in an exam, unless you are told otherwise, you are welcome to approximate g as 10. Absolutely. You can round it to 10 and it'll round your answers and it'll make your answers easier to deal with. And in an exam, that is totally fine. I hope everybody heard that. In a lab, it's a little bit different because in a lab, we're really trying to minimize error and get real predictions and all that. In a test, it is totally fine. And it's not just because I'm being nice. My physics professors did that for me too. Everybody does it. So you could totally make it 10. But now let me also say, here's another reason that question was really good. I'm agreeing that you can say it's 10 rather than 9.8, and it might even be written on a front sheet of the exam. But as to whether it's negative or positive, let me be careful about that for a moment. Negative or positive, that depends on how you make your coordinate system. And actually, now that the person's asking, I will say here in my coordinate system, I call down negative. So yes, then I guess gravity would be a negative number. But actually, that is a choice. Like I had to put this in my diagram, make a choice of whether I call down negative or down positive. And the truth is that now that that person's asking and I'm looking at this problem and I'm realizing that nothing is ever going to go up in this problem. Nothing ever goes up. Everything goes down in this problem. So actually, at the risk of confusing anybody, you can do it this way, the way I have it here. But now that the person's brought this up, the truth is everything is going down in this problem. So I'm going to have a whole bunch of negative signs if I follow this coordinate system, and it's just going to make my life unnecessarily confusing. So now that they mentioned that, I'm actually going to say, good observation. Like, I don't know if this is what they're getting at, but I'm going to say, actually, I'm going to make up negative and down positive. Do you have to? No. But can you? Yes. And do you have to make some kind of choice and then stay consistent with it? Yes. So this is going to be an easier choice to stay consistent with in this problem because everything goes down, nothing ever goes up. So I'm going to make that positive. So I'm going to, yes, it's going to be 10, but it's going to be positive 10, actually. That's a really good, I hope maybe the direct chat person can tell me when they get a moment if I answered, I mean, or if it's clear. But They might have just regretted that they just asked that because I just made a change. Just raise your hand if you see the change I just made in the diagram. Oh, okay, cool. Thank you. But everybody else, great. Great. Okay, thank you. Gianna speaks for the class. Good enough for me. Okay, cool. Okay, cool. Thank you. All right, so that's my, good. All right, so that's my DFP, my step one. I'm just setting up. I haven't solved anything, right? Now I'm going to go, WIQ step two. It's going to be different for each part of the question. Hold on. I just have to go back to the other screen. Okay. So that's, okay. So now I'm doing A. Okay. Time for bomb to hit ground. That's the question, right? In other words, T equals, that's the question. So that's my step two WIQ. And again, for anybody, am I saying that you should do this, the 5-step method for each of your solutions on the exam? Yes, I totally am. Am I saying you have to label each step, whether it's step one, step two? No, you don't have to, but I mean, I don't see why you wouldn't. It would be very helpful to you and to me. Will I take off points if steps are missing? Yes. Will I take off points if labeling it step one or step two is missing? No. But again, anything you think on this exam, should I include blah? The answer is yes. If it occurs to you to include something, include it. Okay. So step two, the question is, what's the time to hit the ground? Okay. Now, the question is, how much time until this bomb hits the ground? This bomb was released from an airplane. It's released. It's falling down to the ground. That's the good news. The bad news is that the airplane is moving forward while this is happening. The airplane is moving forward while the bomb fell out of the plane, just like your ball in lab 4 was moving forward. It got shot off your lab table and it was moving forward while it fell down. That is what is intimidating about both situations. That in both situations, we have horizontal activity occurring while vertical activity occurs. That is why at least one person in the direct chat wants to see this problem and is intimidated by it, because they're like, how do you deal with crap falling out of airplanes, and falling forward or backward? Totally fair to be intimidated by that. But here's the physics insight. The physics insight is, if you want to know how to set up your equations, you want to know what to do, you go to step three. Step three, what is our general definition and principle that will apply to this problem? Well, there may be a number of equations I'm going to use, but the first principle I'm going to set up, I'm going to tell myself, for this intimidating two-dimensional problem, I'm going to remind myself of, of Galileo's principle of relativity, which is really what this whole exam is really kind of about. Form number 5, I'm reminding myself and you can write this, kind of in your own words, but there are only so many ways to say this. Every 2D problem is 2 1D problems occurring independently, yet simultaneously. Now that may seem like some weird, just English or philosophy point that your professor is keeps bringing up at weird times. And it might seem like that has nothing to do with the math that we need to do to solve this problem. But actually, it totally enables us to set up the math to do this problem. Because what it says is, you know what? Even though this plane is moving forward while the bomb is falling, while the bomb is released, or even though the ball in lab 4 was moving forward while it fell down, that's at the same time, but it's independent of the falling down axis. In other words, the amount of time it takes, the time, this is all the kind of stuff I'm writing right now is an example of stuff that you would write to me, but you would write in your words. You show me, don't just copy this word for word. Show me that you get what's going on here. I'm saying, i.e., the time to fall to ground is entirely determined by 1D physics, like 1D kinematics, 1D constant acceleration equations, however you want to say it, one-dimensional physics applied to the vertical axis, the y-axis, the up-down axis, whatever. In other words, y minus y naught equals 1/2 AT. This is all still part of GDP step 3 in a way. I'm saying we have this equation. You might have seen it once in your note, or here, I'll make it even. We have this equation that's true in one dimension that we developed in our notes weeks ago. We have this constant acceleration 1D kinematics equation that looks like this. It's true of any axis at all. It's true as long as you're dealing with one axis at a time. So we originally were doing physics along a number line on the x-axis in a classroom, and we developed all these equations. Now I'm saying I don't care whether that's an x-axis or a y-axis. If you could apply that equation entirely to the y-axis. So acceleration in the y-axis, so I say a sub y. Initial velocity in the y-axis, I write v naught sub y. And instead of saying x minus x naught, I say y minus y naught. Do you have to write it exactly this way? Not necessarily, but I'm just trying to make it clear to you. I'm saying we're taking our one-dimensional equation of constant acceleration, applying it to the y-axis. Now, I'm filling. So now, okay, that's a concept that every two-dimensional problem is two one-dimensional problems at the same time. Now I can start applying this to our particular problem. I mean, I guess I already did by applying it to the y-axis. So going to the next page, okay, I'm just stop me if I need to go back. I'm looking at 3 screens at the same time, so I might not see your chat for a second, but I have this written down. I'm applying it to this problem. Well, in this problem, the acceleration in the y direction is the constant acceleration due to gravity, like what someone in the direct chat put before. So I can say 1/2 g, like, and notice my strategy. I'm postponing numbers as long as possible. I'm doing as much physics as I can before I actually plug in numbers. So my physics is right in and of itself. And then maybe if electron forbid, I make a mistake with a number here or there or a calculator, I'll just only lose a couple of points for that computation error. But I'm doing physics here as long as I can before I plug in the numbers. Why not? What do I mean by why not? I mean where the bomb was initially thrown from, and we can call that 0. There's no reason not to in this problem. Wherever the plane originally was in the y-axis, we're calling 0. And the initial velocity in the y direction, this is very important. Slow down for a second. The initial velocity in the y direction was 0 because the bomb was just dropped out of the plane. It was just dropped out of the plane. It wasn't thrown down. It wasn't thrown up. It wasn't thrown at an angle. It was just dropped. Was the bomb moving forward when it fell? Yes, but that's in the x direction. This is just like lab 4. Your ball got thrust off the lab table, thrust very hard in a horizontal direction, but it was not given any initial vertical thrust or velocity of any kind. So the initial velocity in the y direction is 0. The initial position that it was dropped from is 0. So now I'm getting somewhere. I have y equals 1/2 gt squared plus nothing. What am I solving for? I'm solving for t, time. So I'm just doing all the algebra. Like maybe I did this too quick, but whatever. 2y equals gt squared, right? So now, so the time to fall would be square root of 2y over g, right? again, I'm just doing as much physics. And this also, like the person in direct chat who asked about, like, what do we use for G? Do we use 9.8 or 10 or negative or this? Great question. And I hope I answered it. I think he said I did. I think she or he said I did. But also notice now as a test taking strategy, even if that was, see why I also like that question. If that's a person's question, like what should we use for G, that already shows they already understand a lot about the problem. And if they're proceeding, they're already getting a lot of points on this problem. If their biggest concern in life is what to put in for G, if they follow this method of what I'm doing, of doing as much physics as you can first, by the time I'm even plugging in for G, it's one of my last steps. So even if there was like a wrong thing to do, even if there were a wrong thing to do there, you're going to lose like a point or two. It's like a detail. That's why I'm excited over that question. You're like rocking and rolling if that's your biggest concern, especially if you leave numbers as long as possible in these physics exams. So I'm now, all right, so I'm up to T equals, now I can plug in numbers. This is all still part of step 4, applying, particular application and work. So now I plug in the numbers. What was Y? What here? Here, Y equaled, I think, 1,000 meters. G equals 10 meters per second squared. And notice now we're falling down, but we're calling that positive. And we're accelerating due to gravity down, but we're calling that positive. So it's literally like 2 times positive 1,000 over positive 10. That's, see, if I called down negative, I'd have to make both of these negative. And then what's the point of that? They're just going to cancel out and become positive. But I'd have to make both of them negative because I'm falling down and accelerating down. But a lot of people might only make the gravity negative and they wouldn't realize the displacement is also negative. So then they'd have a square root of a negative and then they get confused or stressed out or wrong or something. Like, I hope you see what I'm saying. You have to make a choice about your coordinate axis and then stay consistent with it. You can't just be making up negatives and positives as you go. But anyway, so T equals square root of 2,000 over 10. Therefore, T equals the square root of 200, but that's not like an exact, so that's going to be approximate. The square root of 200 is I think approximately 14.1. I think better check that, but because I think it's, yeah. And so I think so this is bomb number 1. This is the first bomb that is dropped. I think it takes approximately 14.1 seconds to, yeah, of course. Okay. To hit the ground. I think that's the answer to part A. And I'm going to look at it. What time? So we have 25 minutes. Okay, cool. It'll get faster for me. Oh, chat. Let me look in the chat. Okay, but I think that is the answer. Let me look in the chat. Oh, okay, fine. Oh. Okay, great. Yeah. So someone's asking in direct chat, what if they did use 9.8 and then they would get like 13.5 rather than 14.1? Is that correct? Like, would I give full credit for that? Yes, I would. If you use 9.8 and you get a slightly different answer, totally correct. First of all, you notice we're rounding here, either way, we're rounding. It's a square root. Both of us are giving approximate answers. If you use 9.8 and you got 13.5, yes, you would get full credit. I'm suggesting that you use 10 because a lot of times it'll make your math easier and easier to see. But yeah. I'm not saying 10's more correct than 9.8. I'm just, wait, someone's here. Hold on. But yeah, that's fine. Totally fine. Okay. Wait, hold on 1 second. I'm sorry, someone's yelling for me. But yes, the answer is yes. I said it negative on the previous page. Hold on 1 second. Yes, I'm teaching. Wait, where's mom? Oh, okay, but I'm in the middle of class. What? It doesn't work like that. Hold on. Sorry. Okay, wait, sorry. So that now I just got a question in the direct chat, and maybe tell me, someone said, wait, professor, and this is good. Did I just set up the down as negative on the previous page? Yes, the answer, yes, I did. And I didn't initially because I didn't think, but yeah, so on the previous page, I'm saying down is, oh no, down is positive. Oh, yeah, I corrected it. And I asked if people saw that. Sorry, I originally said, oh no, okay. No, but it's my mistake because I made, okay, cool. My bad, but cool. Thank you. Now, oh, good. Oh, good. All right, someone's thanking me. Okay, you're welcome. And I'm going to keep going. I'm hopefully, but good. I'm glad. I'm very glad. And guys, like really, like, and again, I hope you understand. My goal is for everybody to understand this. And I know from experience, please understand why I don't like exams any more than you do. I mean, like whatever, they stress me out too. But one thing I learned being a physics major, undergrad and in graduate school is like exams are not to find out what you did this is not the pearly gates of heaven. We are not trying to find out whether you really did understand all the things that we said 3 weeks ago. That's what exams feel like, but that's not actually it. The exam is to force us all to understand this. In other words, I'm saying, if you ever feel like you're just beginning to understand things right for the first time, right while you're studying for an exam, or even while you're taking it, that's okay. Like, it took me a long time to realize that is not something to be ashamed of. That is actually the purpose of at least physics exams, is that for many of us, we won't get this until we're seeing it live in a practice exam or if you guys, if any of you, while you're taking this actual thing, suddenly have a moment of insight and you're like, oh, this is what he's been saying all semester. Good. Don't then go, God, if only I had understood this a month ago. No, go, oh, thank God I'm taking an exam. Now I get it. It's not too late. Okay. So if this is making sense to somebody in the room right now, good. I'm going to keep going. But I also want you to know, since I'm not going to be able to finish every single one of these, in 2 days, I want you to know that the stuff that I don't go over here in class, like it is in solutions. The real thing I'm trying to teach you all, I'm not trying to teach you these exact answers. I'm trying to teach you to get used to this way of thinking so that more and more, with less and less information, you can do this on your own. Hopefully, in other words, you'll see as I continue in a moment, you'll see that some of the other problems in the exam are much more similar to the, well, I think one person already realizes this, but some of the other problems in the exam are really more similar to this than you realize when you first look at them. And more, if you look at the solutions to the Coyote Roadrunner problem, at first it's really intimidating, I'm sure, I think, for many of us. But once you've seen this, if you look at the solution to that, you'll see it's very similar to this. And the more these problems start to seem similar to you, the more you are progressing, for real. Okay, anyway, all right, but I'm going to keep, but good, thank you for saying that. I'm going to keep going. Okay, so that was the first one. That was time. Sorry. But keep the things going in the chat, whether it's, good, bad, or ugly. Then, okay, so then B, oh, and this is really what the person was asking about before. I can't remember if it's the same person or not. B, now we ask, how far south, right, of equator does bomb? Last two things. Also, the last thing I put right here, that was step 5, final answer circled. Notice that by the time I got to the final answer circled, it really is the final answer. Like, it has units in it, and it's a full, complete thought, like T approximately equals blah number of seconds for Baum number 1 to hit the ground. Like, it actually refers back to the original question, right? That's what you should do in your final answer. Okay, I think that's clear to everybody. But also, let me say, I had another word of all right, I forgot, but all right. So now part B, how far south of the equator does bomb number 1 land? I feel like there wasn't. I was gonna. All right, so that's. And I should be saying, I'm sorry, I should also be saying for diagram C above. Like you don't have to redraw the diagram every time. As long as it is the same diagram every time, you can say C above. Okay, so that's step one and step two. And this is step two. So what's the question? How far south of the equator does bomb number one land? Okay. My GDP here, again, my step number three, my GDP is the same as before, and you can abbreviate or whatever. Again, GPR form number 5, C above. Now, I'm saying C above because I just explained it above. I mean, at least one time I have to explain it thoroughly, but now I'm in a document here. I'm in communication. I explained above that every two-dimensional problem is really two one-dimensional problems occurring independently yet simultaneously. I'm going to use that principle again here. What do I mean by that? I mean, we're now asking how, well, in fact, I'll be super clear. The two 1D problems occur at the same time. That is the key, that this bomb was falling down while it was moving forward. Now, wait a minute. Why? They're both occurring at the same time. So to cut to the chase, why I solved for the time using the y-axis is because I know something about gravity and acceleration, and I know how far below the plane the ground was. So I used the y-axis to figure out how far, to figure out how much time it takes the bomb to go down. But I'm saying now, while that was happening, at the same time that the bomb was going down, it was moving forward, and I'm going to now figure out how far forward it fell during that time. Now, why was the bomb falling forward? Why? Because it came out of a plane that was moving forward. Like, like there was a bomb sitting in a plane before it was dropped at all. Before it was dropped at all, it was, if you stood in the plane and looked at the bomb, you would notice it moving 0 miles per hour. The velocity of the bomb relative to the plane was nothing. But velocity of bomb relative to plane plus velocity of plane relative to ground gives you velocity of bomb relative to ground, right? So if you, this is all Galileo's principle. So if you stood at the ground and watched the plane and say the plane was like made of glass or something, you know, like a Wonder Woman plane, and so you could see through the plane and saw the bomb on the inside, you would see this bomb traveling across the sky, right? Because it's in a plane that's traveling across the sky. Now then the hatch releases and the bomb falls out. But what does that mean? It literally fell out. We said it was not thrust at any kind of angle. It wasn't thrust up, down, or over. It just fell, right? So if you were in the plane watching the bomb was not given any horizontal velocity relative to you. It maintained the 0. It wasn't given or removed any horizontal velocity. No horizontal force was applied to it, or whatever you want to say. In other words, if the bomb is going 0 horizontally relative to the plane, it's going to continue to go 0 horizontally relative to the plane. So the bomb will keep moving forward relative to the ground at the same forward velocity that the plane is moving relative to the ground. In other words, I'm saying just to be clear, this is still all GDP. Like velocity of bomb relative to ground has to equal velocity of bomb relative to plane, the Yaver bomber, plus the velocity of the plane relative to ground, right? So the bomb keeps going forward as long as the plane keeps going forward, right? It's not attached to it. This is just the nature of velocities. So, or put another way, this is just like the bomb that comes off your lab, comes out of your lab table gun in lab 4. Oops, someone's here. Sorry. The bomb gets shot forward. While it's moving forward, it falls down. Gravity pulls it down, but gravity has no reason to affect anything that's happening in the forward direction. So just like in lab 4, what we say is, we say, okay, like the equation. So in the horizontal direction, displacement has to equal average velocity times time. Or if that's confusing to you, if you want to use the exact same equation we used in the y-axis, you certainly can. You could say x minus x naught equals 1f a sub x t squared plus v naught sub x times t. Like I'm looking at the x-axis now. I'm looking at the x-axis now. It's happening independently, its own physics, but at the same time as the y-axis. So I could write down any equation I want, but here's the thing. In the x-axis, there is no acceleration. There's no acceleration in the x-axis. There's no gravity in the x-axis. Gravity is vertical free fall acceleration. There's no gravity. There's nothing happening in the x-axis. Just like your ball in lab 4, it's just going forward at the same rate it always was. So, and this is 0. So in the x-axis, x equals like the average velocity. So in other words, sorry. So maybe this is something you would explain, like in x-axis, there is no acceleration. Gravity only acts in y-axis. So in x-axis, the average velocity is the same as the initial velocity, which is the same as the velocity at any single moment. The velocity is not changing in the horizontal axis, whereas it was in the vertical axis, right? So we could say in the x-axis, x equals v, that same velocity the whole time. And what is the horizontal velocity in the x-axis? Oh, what is the horizontal? I'm sorry. So we look at the facts of this problem. Apparently in this problem, we were told that an entire plane of, now I forget an entire plane of length 20 meters passes by a marker in 0.1 seconds. You might want to explain this in English, right? But we were told at the beginning that when the front of the plane passes the equator, a clock starts, and then 1/10 of a second later, the back of the plane passes that same marker. So you could think of it in terms of relativity. Think if you were standing on the plane, if you were standing on a plane watching that equator go by, the equator, from your perspective on the plane, the equator traveled 20 meters in 1/10 of a second, right? The equator went from the front of the plane to the back of the plane. From the perspective of the plane, the equator went from the front of the plane to the back of the plane, 20 meters in 1/10 of a second. This is exactly like in lab 4. Some people use 2 photo gates, some people used 1. But if you, I don't know, but if you used 1 photo gate to figure out the horizontal velocity of the ball flying off your lab table, what you did was you measured the diameter of the ball, right? And then you looked at the time that your photo gate gave you, and you said, aha, it took a certain amount of time for the laser to go from the front of the ball to the back of the ball. So it did that distance in that amount of time. That's the horizontal velocity. Oops, sorry. So Vx equals, in this case, 20 divided by 0.1, 20 divided by 1/10, 200 meters per second. And that velocity, this is exactly like lab 4 if you understand the concepts. So Vx equals 200 meters per second. Thus here, x equals Vx times time, 200 meters per second, times approximately 14.1 seconds. Where did I get 14.1 seconds? From problem A, from the y-axis. Oh, whoa, excuse me for a second. Wait, I'm sorry. Someone's at my door that's an hour early. Hold on one second. I'm so sorry. Okay, sorry. Okay, so the 14.1 is seconds from the vertical axis, right? Because they're both happening at the same time. So we just do the computation and we get that x equals approximately 208.20 meters approximately. And your answer will be slightly different if you had used 9.81 in the other part. That's totally fine, but approximately 2,820 meters. Okay, so it's X physics and Y physics happening independently but simultaneously. Okay, that's that. We have 6 minutes more. Well, sorry, I'll keep that. Okay. Okay, now C, the purpose of C. Now this is where, notice all this time, when I'm doing the y-axis, I ignore the x-axis. While doing the x-axis, I ignore the y-axis. All the while, I'm also ignoring all that crap, excuse me, all the, like the supplies that fall down the elevator hatch. Now they come into play. Remember that they were dropped at the same time this bomb was dropped. So it says in part C, at the moment that the bomb touches down the ground, is the elevator cage already there? Should it arrive later, earlier? How much time should the elevator cage take to fall as compared to the bomb? What's the purpose of this whole thing? The purpose of I'll tell you the answer first of all. So like, how should time of descent The answer is the time should be the same. Now, you're going to want to explain this in your words on the exam. I'll explain in my words right now. and don't just copy that. I'm writing y-axis independent of x-axis. If you literally just copy that, I will know that you literally just copied that. I'll explain what I mean by that. I'm saying that the whole way we figured out the amount of time it took the bomb to hit the ground, like the bomb, and we're going to find this out in a future question here. Like, if you're really picturing this correctly, you'll realize the bomb is, if you stood, well, it's going to ask you this in two parts, but if you stand at it and watch the bomb, it doesn't go straight down. It goes in an arc like the bomb in your lab 4, because while it's going down, it's also going forward. But what we're saying is those two aspects of its motion are occurring independently yet simultaneously. We're saying that the amount of time it takes to fall, all you have to look at is its free fall acceleration due to gravity. What literally, in other words, the analysis we just did, the calculation we did in part A, absolutely assumed that if a bomb was falling out of an airplane while an airplane was going forward, if a bomb fell out from the same height and at the same time, that something was just dropped, what we're assuming is that they both take the same amount of time to hit the ground. Put another way, if you stand somewhere and you shoot a gun forward while you drop a bullet from the same height, if you shoot a gun forward, if you shoot a bullet forward while you drop a bullet at the same time from the same height, one bullet will go really far before it hits the ground. The other won't go far at all, but they'll both hit the ground at the same time. That's what we're believing when we do all this physics and we do all these calculations. So the elevator can, and so any ball that you just dropped from your lab table while you shot the other ball off your lab table, they should both hit the ground at the same time. That's what our calculations are assuming. That's what this is asking. So you can put that any way that's correct, but it's the same time is the point of C. Then D, all the rest of these questions are actually just trying to force to make sure that we're picturing the correct physics for the calculations we did. So then when should bomb 2 hit the ground? How much total time will elapse from release? Well, if it's released 3 seconds after the first one, all the physics is the same for each bomb. All the physics laws and the calculations are the same. So I'm going to rush now a little bit because there's only 2 minutes. So we know the question. I'm just going to say answer 14.1 plus 3 seconds. In other words, approximately 17.1 seconds. I mean, they're just going to be separated by 3 seconds now. Yeah. Where should we expect to find bomb number 2? How far horizontally displaced from bomb number 1? Well, I'm doing this again quickly because we're about to run out of time, but no, sorry. Yeah, I mean, the second bomb was 2,000, like the bombs are all going 2,000 meters per second forward. So the second bomb 3 seconds later was 6,000 meters ahead of the first bomb, right? I mean, we're just dividing the questions into horizontal and vertical. I know there's 1 minute left. So here's the main, and these solutions are in the packet that I just put in Google Classroom. But here's what's simple but not easy. If you get this picture, then you get all these calculations. If you don't, then you want to think about it. But wait, so I'm skipping F for it. I'm just talking about G and H. What I want you to know is I'm skipping F. You can look at F in the packet, but G, if you were a photographer just looking at this whole situation, what I want you to know is all the bombs. Look at the cover of the whole exam. They're just like in the cover of the whole exam. At any given moment, all these bombs would be in a vertical line below the plane, which is surprising. Like you want to think about this when you're studying at home, but I'm saying the bombs would just stay in a line with the plane because the bombs are each bomb is always going forward at the same rate as the plane. They're not going to trail back. They're not going to thrust forward. They're all going to stay in line with the plane because they're all going at the same horizontal velocity. That's what a photograph of all the bombs would look like. But a movie of any individual bomb would be going in an arc toward the ground. Think about that. I know class is over and someone is here for me that I didn't expect, but think hard about that. That's two different statements. The bombs in a photograph would line up, would be in a vertical arrangement below the plane. That is surprising, but it makes sense if you understand everything I just did. But any individual bomb, if you took a movie of it, would be falling forward while it falls down, and it would be doing so, therefore, in an arc, just like your object in lab 4. So there's another solution, a different video will be posted of a different solution. All the rest of the solutions are in the packet. Plus, we'll talk more about this on Wednesday, but hopefully that helps. Okay, I'm looking in the chat. Wait, sorry. Yeah, okay, very quickly. So if you got to go, you got to go. I mean, I got to go in a second too, but there's a good question in the chat if anybody wants to stay. So there's a question in the chat of, could we explain it by showing the calculations and showing that you would get the same answer? And I believe he's talking or she's talking about the time thing, see, I'll just say, the point is that the calculation is literally the same calculation. It literally is y equals 1f at squared plus v naught yt, and v naught y is 0, whether you're talking about a bomb or you're talking about the elevator cage. The whole point is that the calculation would be the same. The calculation is y equals 1f at squared plus v naught yt, but v naught in the y direction is 0. So it's y equals 1/2 at squared, and you rearrange and solve for t. If the person who's asking, you guys can go, if you, I will go in a second, but the person who's asking in direct chat today, okay, cool. But the person who just asked me that, cool, bye. But the person who just asked that is still here, did I can say more if you want. I don't need to keep the other people, but did that make, okay. All right, cool. Okay, cool. Okay. So thank you. Thank you. You too. Enjoy the rest of your day. Awesome. Okay. Okay. I'm turning off.